do this. This gives us enough writing space, I think. You need a lot when you're doing these partial.
Right.
But, so the bottom factors out to what?
The bottom factors out to -4 and -3, so x minus 4 and x minus 3.
So we get a times what?
2x plus 1 equals a times x minus 3 plus b times x minus 4.
This seems straightforward enough.
Yeah, so just plug in -3, I guess.
Hold on, be careful. You got to make that equal to 0.
Oh, yeah, it's not an addition sign. So plug in the 3.
Okay.
So then 3, so then it would be b times -1 equals 7.
Yeah, so b equals -7.
Right.
And to solve for a?
So then 4, plug in for x. So then 1. So then a equals 9.
Okay. So now you have the integral of
9 over x minus 4.
I think it's, yep.
Plus the integral, or minus rather.
Yep.
Minus the integral of 7 over 2, or x minus 3.
Okay. I didn't write everything out this time. Is that right? Yeah. Okay.
So then we can pull out the constants.
Yeah, you don't necessarily need to do that as a secondary step.
So it's just 9 ln x minus 4 minus 7 ln x minus 3. Let's see.
Yeah, and I don't know how exact your teacher is in insisting upon these absolute value signs also.
He just has them write it. He's not like too strict about it, but
that would be the proper final answer.
Right, yeah.
Okay. All right. Let's do a little harder one. Well, 5 isn't really harder. Actually, it is a little bit. I mean, it's a little different. Let me think about this for a second. Do the instructions say just do these however you can? They don't specify you have to do them by partial fraction decomposition?
Well, the practice is for partial fraction decomposition.
Okay.
Like specifically, but I imagine you can do it other ways.
Okay. I don't actually see other ways to do this. I was just curious since I can't read the top of the sheet here. So how am I going to set this up?
Well, A over x minus 1 and B over x minus 1?
Um,
I'm not sure.
I think it's got to be this. And I think it may even be that. In other words, if we were adding the two bottom things together, what would be the common denominator? I'm sorry, if we were adding the right side of the equations together.
The right side of the equations together? I'm not sure.
Well, it's x minus, it's x minus 1 squared.
Oh, well,
You don't need to multiply those two together and get x minus 1 cubed.
right.
A least common denominator is this one right there. Okay, but you might also have that. In other words, you can't assume the whole denominator is x minus 1 squared. And notice that if we did have what you first suggested, a over x minus 1 plus b over x minus 1, the common denominator would be x minus 1.
Right.
Okay, so in order for there to be a square, we kind of need to set it up like this. I'm going based on memory here rather than out of my book. I'd have to find it in my book.
I can find the answer explanation too.
Well, let's just go with this for a moment.
Okay.
Okay, so let's see what happens here. I may need a C on the end of that also. I'm not sure. So this would be a times x minus 1 squared plus bx times x minus 1. I know this, that you have to introduce an x into the numerator when you have an irreducible quadratic as one of your factors, which we have in number 6. Number 5 is not necessarily an irreducible quadratic, so I'm not sure we need the bx. In fact, let's get rid of it and see what happens.
I think I think we'd be good with just the B.
I think so too, and that's what I'm going to try here. We're going to need to use the x on number 6 because that is an irreducible quadratic, and that's what you look for.
Okay.
So if we do it this way, we'll be able to check and see if this is right. Easy enough. We get this, and this all has to be equal to 2x minus 1.
Right.
So you expand that, you multiply it by a, distribute everything, and now you gather like terms and factor out that like term.
Okay.
So let's see, where can I write here? I'm going to change the color so you'll pick up on it up here in the upper left. We have ax squared minus, let's see, we have a minus 2ax plus a bx, which is a minus x times b minus 2a.
Okay.
And you put the constants together, and we have a plus a minus b. So we have our squared term, we have our middle x term, and we have our constant.
Okay.
Now, A has to be 0 because we don't have an x squared term on the left.
Right.
That has to be equal to this. So let's see, I think we can actually solve everything just based on the fact that that has to be equal to -1. And if,
Right.
if A is 0, then B has to be -1.
Right.
Unfortunately, that does not work.
Well, so when we separate the A times x minus 1 plus B times x minus 1, don't we multiply? How are we getting that? Because maybe something cancels when we do that.
Yeah.
Just because it's like similar fractions. I don't know.
No, you got. We're doing something wrong for sure. Here, let me go back. And that's valid. Let's see. So let's go back to this step right here. So if I was adding what's on the right side of that equation,
We gotta multiply by x minus 1 squared, right?
no, this is the common denominator. So in the numerator, I need one of those. In other words, now that term is equal to the term above it. Oops, hold on a second. Hold on a second. Yeah, it is. Okay, plus B, it's not B times x minus 1. It's B times over x minus 1 squared. Right?
So it's just A times x minus 1 plus B.
Yeah. That's what's equal to 2x. So 2x minus 1 equals ax minus a plus b.
Okay, that makes sense.
So a would be 2.
Right.
And if a is 2, then b has to be 1. To make that 2x minus 1.
Right.
And therefore, that's a 2, and that's a 1. Yeah. This is a little different, and I just made a mistake in the algebra is all I did. Everything else is pretty much the same. Well, this step where you go from this to both of those is not obvious. That's a step you have to kind of remember. When you have a linear term squared, you have, that's what it is. When you have a linear term taken to a power, you have to account for every degree of that. In other words, if this was x minus 1 cubed, then I would need an x minus 1, I would need an x minus 1 squared, and I would need an x minus 1 cubed.
Okay.
So I would have A, B, and C if this were x minus 1 cubed.
Right.
Still don't need an x in the numerator until you get to these irreducible ones.
Okay.
Okay. Let's see, I guess we're good with that as an answer. Or hold on. Hold on a second. It's okay, so tell me the answer. What's the integral of that plus the integral of that?
2 ln x minus 1 plus.
See the problem.
Oh, yeah, because we're integrating. It's not an ln anymore.
Right. we're integrating the following. We're integrating x minus 1 to the minus 2 power.
Right. So that'd be...
Do that just using the power rule.
Right, that'd be 1 over x minus 1.
Let's see. Well, it'd be minus, first of all. Right?
Right.
And it's minus 2. Oh, excuse me, we're doing integration. We're adding 1, and then we're dividing by the new exponent. So it does make that a minus sign.
Right.
But it's x minus 1 to the negative 1.
Right.
Plus.
So if that was multiple choice, it could also be written 1 over x minus 1, correct?
Yes. Yes.
Okay.
Most definitely. In fact, it can also be written plus 1 over 1 minus x.
1 over 1 minus x. Oh, yeah.
Because if I turn the bottom around and make it 1 minus x, it becomes the negative of the top.
Okay.
You could write it like that.
Good to know.
Yeah. Okay, let's look at one of these non-irreducible ones. See if I can remember how to do these. So we have, here's what our 3 fractions are going to look like. Now the reason that's called non-irreducible, not only can't you factor it, but it doesn't have any zeros. That's always a positive number. There's no way to make that term 0. Because x squared is always is always positive.
Oh, yeah, that's true.
And then, do we need it there or do we need it? I'm pretty sure we need a C. The question is, what's it go over?
X.
I'm going to take a wild guess here. And does the X go with the C or does it go with the B? I can look it up if you want to hang for a couple minutes. We don't have that much time. Hold on a second. I can look it up pretty fast, I think.
Yeah, it's okay. I want to know how to do these. I haven't seen these yet.
These non-irreducible ones are the harder ones. So let's see if I can find partial fraction decomposition 85. This is actually in my pre-calc book. All right, good. This is the page I needed to be on all along. What we were doing was non-repeated linears. Which is what I was just telling you. In other words, if you had an x minus 1 cubed in the denominator, you would need an x minus 1, an x minus 1 squared, and an x minus 1 cubed.
Right.
Okay, here we get the non-repeatable, irreducible quadratic. In the example, hold on, it's bx plus c in the numerator. That's what it is. It's this. It's like that. Ooh.
Okay.
Hold on a second. Or is it? Just a second. Let me just take a quick peek on how they are doing this. Yep, that's exactly how they're doing it. So this should be the way to go. And now it's just algebra. And this has to equal 1. This one right there. Okay, so what does that mean? That means a times x squared plus 1 plus bx plus c times x plus 1, right?
Right.
Okay, let's see what that gives us. Ax squared plus a plus, let's see, that's bx squared plus a bx plus a cx. So plus
Right.
x times b plus c plus c.
Right. Equals 1.
Equals 1. And now we want to gather all like terms together. So we have a plus b times x squared
Right.
plus, let's see, we have a bx and a cx, right?
Right.
And that's the only ones we have, so I can just leave that as is. B plus c times x. And then our constant is a plus c.
Right.
And all that has to equal to 1. So a plus c has to equal to 1.
Right.
A plus b has to equal to 0. And b plus c has to equal to 0. That doesn't compute. In other words, if I add these two equations, oh, maybe it does compute. Let's see, if I add these two equations, I get a plus c plus 2b equals 0. A plus c equals 1, so I get 1 plus 2b equals 0. I get 2b equals minus 1, b equals minus 1/2. So we got a b equals minus 1/2. Since a plus b equals 0, a has to equal plus 1/2. And c has to equal plus 1/2.
Okay.
So that looks like a solution set. Let's go plug it in. Let's see, I guess I can plug it in at this level right here. So A, we'll use blue, it'll stand out. So A is 1/2. B is, no, A is plus 1/2, B is minus 1/2, and C is plus 1/2, right?
Right.
So if I multiply that out, let's erase everything below it so I can do the math. We should end up with 1. In other words, that should equal 1, right?
Right.
So we have 1/2 x squared plus 1. What is this? Is a minus 1/2? Yeah. So that's minus 1/2 x
Plus
1/2. Hold on. Times x plus 1. I got something wrong here. There's a plus sign right here.
Right.
Now, is that going to get rid of my x squared? I don't see it. Oh, maybe. Yeah, no. Yeah, it might be. It might. We got to multiply. Got to FOIL these two. So when I FOIL,
Squared.
what do I get when I FOIL those? Let's see. I get minus 1/2 x squared. Then I get a minus 1/2 x and a plus 1/2 x. So the middle term disappears. And I get a plus 1/2. Ah, the x squareds do disappear. The x's are gone. And I get a 1 plus 1/2. So close. It's got to be a math error I did.
Yeah.
1/2 times x squared plus 1 is 1. There's a half right there.
Oh, okay.
Distributed to the whole thing. And now your x squared disappears, your x disappears, and you have plus 1/2 plus 1/2 equals 1. So
right.
We did it right. Now the question is can we integrate it? So A again was 1/2, B was negative 1/2, and C was plus 1/2. So
right.
See what happens when we go to integrate that. Is it hard or doable? Should be relatively straightforward. These techniques, I don't remember anything special you have to do after that. Although the middle term's giving me problems already. Let's see, so that's 1/2 natural log of x plus 1.
Right.
We can do this. Over here on the left, you can tell that when you have an irreducible quadratic in the denominator, the problem takes twice as long, at least.
Right.
Because now we have to figure out how to integrate this. I'm going to take that minus 1/2 out there for a moment, and let's just make it x over x squared plus 1. What technique are you going to use to integrate this?
Use substitution.
Yeah, because this x represents the degree of the derivative of what is going to be u.
Right.
Only thing it needs in front of it is a 2.
Right.
I'm going to put a 2 in front of it, and I'm going to take a half out, turning that into a quarter.
Right.
Okay?
So it's just negative 1/4 times ln.
Not
x squared
ln.
plus 1.
Not ln. In other words, we're now going to use the power rule on this.
Well, I thought it'd be 1 over u.
It would. How do you integrate? It's not 1 over u. No, you might be right. Yeah, you are right. It is the natural log of x squared plus 1.
Okay.
Let's see. If I took the derivative of natural log of x squared plus 1, I would get 2x all over x squared plus 1. So yeah.
Okay.
Okay, so that's minus 1/4 natural log of x squared plus 1. That definitely does not need the absolute value sign. What do we do with that 1/2 on the end there? I can separate that into 2 fractions.
Right.
So that.
So it's 1/2 the integral of 1 over x squared plus 1.
Which is negative 1 over x squared plus 1 to the, no it isn't.
Wouldn't it be,
Here's the integral of that. Over here on the left again, let's take the integral of that last term.
wouldn't it be an inverse trig function?
Maybe. I don't know.
It's x squared plus a squared, 1 over x squared plus a squared.
I'm going to take that 1/2 out. Oh, you're right. You're absolutely right. Yeah. So you think that is the inverse tan of
Yeah, I just didn't know which one it was.
x squared plus 1. No, of x.
Yeah. Yeah, I think that's it.
If I took the derivative of that, I would get 1 over x squared plus 1.
Right. So yeah, I think that would be the answer. 1/2 tan inverse tan x plus c at the end.
Wow.
That's a long one.
Not only long, but tricky, all kinds of different things in the answers.
Right.
And would I bet my life on that? Heck no, because I could have easily made a little bit of a math error.
Right.
But if you're looking at multiple choice, and that's that's the one to go with.
Right.
I'm taking you over your time.
It's all good.
I'll let you go, and we'll tackle number 7 next time. 7 is the same thing. Oh no, it isn't. It's not an irreducible quadratic. It just requires 3 terms. It's going to require, I think. I don't know. I'm going to have to look at that a little bit. So I will talk to you tomorrow.
All right. Talk to you tomorrow.